This video will discuss chapter 8.6, slope. Slope is one of the most important concepts in algebra, so I want to make sure that we have a very clear understanding of it. And there are two ways that we really talk about slope. And the first is we talk about rise over run, and you're going to hear this phrase often when we're discussing slope. And it's the idea that we first use the rise, which is the y, over the run, which is the x. So it's rise, then run. Okay, and it's written in the form of a fraction. And the other way, and this is kind of more the formula, is y2 minus y1 over x2 minus x1. And we're going to talk about these 2's and the 1's, but remember these are subscript, not necessarily superscript, and superscript is when it's up there, and that you probably think of as exponents. These are not exponents, so these are just talking about points on the graph. And you've actually been doing this as we've been working on rate of change. We talked about y equals kx for direct variation, and k was the constant rate of change. And what you're going to find out is that k is the same thing as slope. And so rate of change is slope. Rise over run, y2 minus y1, x2 minus x1, rate of change, all of these, or constant rate of change, all of these things are slope. So I'll come back to this in just a second. Let's talk about this drawing, very primitive drawing of a skateboard ramp. So think of it kind of as this ramp going up, and so you've got 15 inches in height and 54 inches in length. And so if I was going to do this as rise over run, this would be 15 over 54. Right? If I wanted to reduce this, I would have to reduce this. So I'm going to divide by 5, and so, I'm sorry, not by 5. 54 isn't divisible by 5. I'm going to divide by 3. So that will give me 5 on top. 54 is divisible by 3. 18 times 3 is 54. And so 5 over 18 would be my rise over run of this skateboard ramp. Right? So for every 5 inches that in rise, I would have 18 inches of run. Or for 5 inches of height, I'd have 18 inches of length. So that's the idea of rise over run. Now let's talk about how we would see this on a graph. So you're given 2 points, R and S, and these are the coordinates of R and the coordinates of S. And I need to find the slope of the line that contains these 2 points. And so what I need to do is label them, keeping in mind that this is x and y, right? So as you write coordinates or you see coordinates, it's always x, comma, y. I'm going to call this point x1, and I'm going to call that y1. And make sure that that is a y. And then I'm going to call this x2, and I'll call that y2. Now, in the end, it actually doesn't matter which one you call 1 and 2, as long as both of these are 1s or 2s, and then these would be the other. So this could have been x2, y2. You just can't go x2, y1, x1, y2. Right? So the idea is I'm calling this point 1, I'm calling r point 1, and I'm calling s point 2. And so this is the x and y of point 1, and this is the x and y of point 2. For people who don't understand or are often confused, the easy thing is to make the first point always make it 1, and the second point to always make it 2. And in this example would matter. There are times when it's easier to make this the 1 and this the 2. But again, if that's going to confuse you, then it's not easier. So don't worry about it. So I'm going to use the formula. And if you remember, this is the formula. y2 minus y1 over x2 minus x1. So this is going to be y2, which is negative 1, minus y1, which is 3, over x2, which is 4, minus x1, which is negative 2. You've got to be very careful that you're writing in all the negatives where they're supposed to be. And remember, these are always subtractions. So the formula is a subtraction problem. Right? y2 minus y1, x2 minus x1. You know, and if you think about rate of change, it's the change in y over the change in x. So, coming back to problem we're solving, negative 1 minus 3, and so this is where sometimes it gets confusing, so just be careful. Negative 1 minus 3 is negative 4 over 4 minus negative 2, so remember there's a trick where we can turn those both into pluses, and this becomes 6. Negative 4 over 6. Now I just need to reduce that, And so my slope is going to be negative 2/3. So this is where sometimes people are confused. How did you move the negative from the numerator to out in front of the fraction? And so remember, it doesn't matter which way you go. And so if you think about it, a lot of times the example that I would use is this one. 2 over negative 1 or negative 2 over 1. All three of these, this one, and this one, all say negative 2. Negative 2 divided by 1, 2 divided by negative 1, negative 2 divided by 1 are all negative 2. So it doesn't matter where you put the negative sign, and so usually in the answer, the negative sign is out in front of the fraction. It says the same thing if it's there. It's just, ideally you're going to start to get comfortable putting it in front of the fraction. So the slope of the line that contains these 2 points is negative 2/3. All right, now let's take a look at some special circumstances. So the point that contains a and b, we're going to try to find the slope. And again, I'm going to use this formula, y2 minus y1 over x2 minus x1. So x1, y1, x2, y2. y2 minus y1, that's 4 minus 4 over x2 minus x1, 2 minus negative 3. 4 minus 4 is 0. 2 minus negative 3 becomes positive 5. 0 over 5 is the same as 0. So my slope is 0. Okay, a lot of people get panicked and they say that that is the empty set. It's not the empty set. It's 0. Okay, the slope of this line is 0. And in fact, a slope that has or a line that has a slope of 0, if you think about it, is a line when the rise is 0 and the run is 5, so it never rises but it always runs. You're going to get a line that is parallel to the x-axis. This line will look like that. It's going, sorry, I'm off to the side. This line will look like that. It's going straight across, right? It's a horizontal line that has a slope of 0. So a slope of 0 will look like this line. Coming to this one, and some of you may be able to guess what's going to happen here. y2 minus y1, 0 minus 3 over x2 minus x1, 1 minus 1. This becomes negative 3 over 0. Now, if you were to take your calculator and divide negative 3 by 0, you're going to get some kind of error message. To divide by error, 0 error, or sometimes it just says error. And so the idea is that you can't divide a number by 0. You can't have, and you probably learned this when you learned fractions, you can't have a 0 in the denominator. A 0 in the numerator is okay. A 0 in the denominator doesn't work. So this is a line that is undefined. See how well I can write off to the side. It's a pretty ugly F. Undefined. And so this line, which is kind of the opposite of this is a line that always rises and never runs. So you come back and you're looking here, if this is a number but this is a 0, this line will always rise, but it never runs. So it's just going straight up and down. So this is parallel to the y-axis. So an undefined slope will look like that. Straight up and down. All right, so this is a slope of 0. This is a slope that's undefined. And then another line that might, that has a slope, for example, the negative 2/3 is just one that goes down 2 and runs 3. Right? So as you were to graph it, you can kind of see what that might look like. All right, like I said at the beginning, slope is a very important concept, possibly the most important concept when it comes to algebra. So it's really important that you understand what you're doing and that you're able to practice some of these problems. Thank you for watching this video. Please don't forget to do the problems in the bottom of the page. I'll see you in class.